Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 1 for May-June 2019, and the code is 9709/61. So let's get started. Okay, question number 1, the times t seconds taken to swim 100 meters were recorded for a group of 9 swimmers and were found to be as follows. That means all these are the t values. Okay, how many seconds? First part, find the values of summation t minus 120 and summation of square of x t minus 120. So since all the t are given, I will just direct calculate t minus 120 from all the t. That means that is going to be 95 minus 120 for the first t, and then plus summation means plus with 126 minus 120 plus 117 minus 120. Then the next is 135 minus 120 followed by 120 minus 120. Then next is 125 minus 120 followed by 114 minus 120. Then 119 minus 120, and lastly 136 minus 120. Then from here, each of the calculations will be minus 25 plus 6, then plus negative 3, then plus 135 minus 120 is actually 15, then 120 minus 120 is 0, plus the next one is 5, 114 minus 120 is minus 6, then 119 minus 120 is minus 1, lastly 16. So when you get the total of all these numbers, that is going to be 7. So done for the first summation. And then the next summation is summation of t minus 120 squared. So it means that now I have to square all these values. Alright, so it will be minus 25 squared plus 6 squared plus minus 3 squared plus 15 squared plus 0 squared plus 5 squared, then minus 6 squared plus minus 1 square plus 16 square. Then from here, you will be getting the answer of 1213. So that's the solution of this question. Okay, next part. Using your values found in part 1, calculate the variance of t. Okay, just now, variance of t minus 120. Go back to the definition. Variance of x is basically summation x squared over n minus mean squared. So since we have counted summation t minus 120 square and summation t minus 120, so it means that now your x has been changed to t minus 120. That means this is going to be t minus 120. Okay, so even though we are asked to calculate the variance of t, but I need to calculate the variance of t minus 120 first. That means this is going to be summation of t minus 120 square over n, then minus the mean square. Mean square is actually summation x over n. That means this is, then you square it. Okay, then this one becomes summation t minus 120 over n. This is our mean, and you square it. This is a formula. So variance t minus 120, that is going to be 1213 over 9 minus the summation is 7. So 7 over 9, you square it. Okay, then this is going to be 10868 over 81. And this is going to be 134.17. So if I round up to 3 significant figures, that is 134. Now, but then the question asking for variance of t. Okay, so we know that according to the coding method, variance t minus 120, or probably you can just use the linear combination method. This is going to be same as variance of t. That is, I will write variance t, because you are asked to calculate variance t. Then this is same as variance of t minus 120, which is same as 134. Okay, that's why I'm counting variance t minus 120 first. Alright, so with this, I have done the question number 1. Now, question number 2, Jamil has 5 plums and 3 apricots. Rosa has X plums and 6 apricots in a box. One fruit is chosen as random from Jamil's box and one fruit is chosen as random from Rosa's box. The probability that both fruits chosen are plums is 1 over 4. Write down an equation in X and hence find X. Okay, so that means now, if probability of both fruits are plums, that means it should be plums from Jamil. Okay, this is plum from Jamil, or probably I just write plum from Jamil and plum from Rosa. Right, R means Rosa. Then it will be 1 over 4. So that means now here, at first, Jamil has 5 plums out of total of 8, because total here is 8. So the probability is 5 over 8. So now times with, okay, X plums over X plus 6. So this is the total of the fruits in the second box. Then it will be 1 over 4. Okay, then from here, write down an equation. I will say that this is the equation. Then now, I will just simplify. So multiply 5x over 8 times 6, 48. Then plus 8 times 8x, 8x equals to 1 over 4. Then from here, just use the cross multiplication to solve this problem. Just multiply. Then I will be getting 20x equals to 48 plus 8x. And now you need to find the x. Okay, so the 8x will be moved to the left side. Then I will be getting 12x on the left side. That equals to 48. That means now my x equals to 48 divided by 12. That is going to be 4. Okay, done for this question. For question number 3, a fair 6-sided die is thrown twice, and scores are noted. X means the total of the 2 scores is 4. The Y is defined as the first score is 2 or 5. Are the events X and Y independent? Justify your answer. Okay, for independent events, that means Px intersects Y equals to Px times Py. Okay, that is the independent events definition, Px times Py. Okay, therefore from here, I need to build a table. Probably I just draw a table. So here will be 1, 2, 3, 4, 5, 6. Okay, so because it's mentioned 6-sided die and it is fair, so this is the first thrown, and then this will be the second thrown. Second throw. Okay, first throw and second throw. So now here again 6 numbers. Alright, so now the x means the total of 2 scores is 4. So it will be 1 plus 3, that is the x, to get 4. Maybe 2 plus 2, maybe 3 plus 1. That's all for the x values or x outcomes. Okay, so for the y, the first score is 2 or 5. So first score is 2. Okay, all this will be first score. Means you get the score from first row, or it is 5. Okay, then from here, I will say that my Px intersect y. So we know that a fair die has 6 faces and it is thrown 2 times. So the total probabilities is, total outcomes is 36, because 6 times 6 is 36. And now x and y, x intersect with y is just 1. Okay, then Px, it will be just 3x. So therefore the probability is 3 over 36. And then py, obviously, you just count how many y. There will be 12 over 36. So now I calculate the multiplication. Px times py. This is going to be 3 over 36 times 12 over 36. And you will be getting 1 over 36. So 1 over 36 is same as the intersection probability. Right? So from here, you just write, since px intersects y equals to px times py, therefore, or hence, x and y are independent events. Okay, so done for this question. Question 4. The Mathematics and English A-level marks of 1,400 pupils, all taking the same examinations, are shown in the cumulative frequency graph below. Both examinations are marked out of 100. Okay, so you are given cumulative frequency and also the marks, two graphs. The dotted line graph is for English score and the solid line graph is for mathematics. Alright, so now use suitable data from these graphs to compare the central tendency and spread of the marks in mathematics and English. Okay, so basically this central tendency means median, right? Or I would say that it is mean as well. But then since we are using the graph, the cumulative frequency graph, means that now we are referring to median. It can be mean, median, and mode. Okay, central tendency itself. Mean, median, and mode. Okay, but according to the graph, you are just able to get the median. Then this spread is actually the interquartile range. That is the Q3 minus Q1, the upper quarter minus lower quarter. So now means that now I have to get the information for English, the median. Okay, median is basically is half of the total F. Okay, the total F here is 1,400, right? So since this is the cumulative frequency curve, we do not plus 1. We will just write 1,400, and then that is the position of 700. So then the value itself, now let's look at the English, which is the dotted line. 700 is over here. So use a ruler to draw the line, and then it is in the middle of this. So, okay, it's in the middle. So this is going to be 51, 52, 52.5. Right? Wait, sorry. You have only 5 squares. Okay, 5 squares but 10 units. That means, okay, 5 squares but 10 units means that it will be 2 units for each square. So it will be 50, 52, 54, 55. So this is a 55. That is a median. Okay, then the Q1, that is 1/4 of 1,400. This is the position, that is 350 data. So now let's check 350. Okay, again here, see 100, there are 5 squares, but for 100 units, that means each square is 20 units. And now you need 350. Okay, 350, that means, so it will be in the middle. This is 350. So when it is in the middle, that means you will be getting this value. So this is going to be 42. So here I will get 42. And so same concept goes to the Q3. That is 3/4. So 3/4 it will be 1505. That is the position of the data. So sorry, not 1505, 1050. Okay, 1050. And again, each square is 20 units, right? So 1050, it will be 10. Here is 20, 40, 50 is over here. So it's in the middle. Okay, so this is 62. There's a Q3. This is Q1. This is the median. So 62, right? So here I will get 62. That means the interquartile range IQR is Q3 minus Q1. That is 62 minus 42. Then I will get 20 for the English marks. Now repeat all this calculation, all this for math, right? So for median, it will be again data number 700. Then now just read from the graph. Now we refer to the solid line. Okay, 700 is over here. So the solid line is over here. This is a solid line. That is 40. Okay, so median is 40. Then Q1, that is the data number 350. And then the Q3 will be the same, 1050. Now just read from the graph. Okay, it's here. That is, okay, 2 units for 1 square. This is going to be 12. This is our Q1. So 12. And then for Q3, this is 1050. That means just extend it. So obviously that is 80. This is your Q3. Okay, so now here I will write 80. That means the IQR, interquartile range, is going to be 80 minus 12. Then you get 68. So now, for the center of tendency, you compare these two medians. And then for the spread, we compare the IQR, interquartile range. So from here, obviously, for English, the median is higher than math. And then the interquartile range, English is lower than IQR. The IQR for the English is smaller than math. Okay, so I will write here, English marks has larger median but lower IQR, interquartile range, lower spread. Or I would say, yeah, lower spread because of lower interquartile range compared to math marks. Okay, so that's the comparisons. Okay, now question number 5. In a certain country, the probability that a child owns a bicycle is 0.65. First part, a random sample of 15 children from this country is chosen. Find the probability that more than 12 own a bicycle. So now this is binomial distributed because of the children is is discrete random variable. So the n is 15, then the p is 0.65. Okay, because your formula is supposed to be x is b and p. So probability of x equals to x, it will be ncx, px, qn minus x. And then the x is starting from 0 until n. So from here, my p is 0.65. Then my q is going to be 1 minus 0.65. That is 0.35. Okay, then now we need to calculate more than 12 on the bicycle. So px greater than 12. So greater than 12, I will just direct count because the maximum is up to n, maximum up to 15. So I will say this is 13, 14, and 15. Just plus these three probabilities. And now apply this formula, binomial distribution formula. 15 C13, 0.65 degree 13, 0.35 degree 2. Okay, that is the first probability. Second probability is 15C14, 0.65 degree 14, 0.35 degree 1, and then plus with all success. Okay, then from here you will get 0.047555 plus 0.0126167, and the last value is a very small number. So when you add up all these three values and round up to three significant figures, that is 0.0617. So that's the probability of more than 12 own a bicycle. Part 2. A random sample of 250 children from this country is chosen. Use a suitable approximation to find the probability that less than 179 own a bicycle. So now your n is 250. Okay, which is greater than 50 now here. Then the p remains at 0.65. So now I need to calculate my NP. 250 times 0.65, then you are getting 162.5, which is greater than 5. Okay, so when NP is greater than 5 and n is huge number, greater than 50, therefore we will approximate it to normal distribution. So normal distribution, we need the variance, which is the NPQ. So now NP is counted as 162.5. Your Q just times by 0.35. So then from here, you will be getting 56.875. So then I will write X supposedly binomial distributed, N is 250, P is 0.65. Now it has been changed to normal distributed. The mean is 162.5 and then variance is 56.875. Okay, then from here, you will have to calculate probability that fewer than, so less than 179. So when less than 179, remember this is discrete. Binomial means discrete, but then normal is continuous. So from discrete change to continuous, we need to consider the continuity correction factor, which is plus minus 0.5. So I will label 179, but less than 179, basically it is 178, 177, and so on. All these will be the x values. And now you are allowed to plus or minus 0.5 from the given x, which is 179. So when I minus 0.5, that is 178.5. When I add, it will be 179.5. Now, when you look at the question here, this is x less than. So when we convert, it will be w less than. So follow the sign. So when less than, so obviously it is towards the left side. So now I have to choose whether it's less than 178.5 or less than 179.5. So obviously, to include these two ticks, I have to choose less than 178.5. That is how we decide whether you plus 0.5 or you minus 0.5 from the given x value when you are using normal approximation to binomial distribution. Then after this, right now it is normally distributed, and again when you refer to the normal formula, the normal distribution formula, when we standardize it, it will be x minus mu over sigma. So which means now here I will be getting PZ less than 178.5 minus the mean is 162.5 over, remember this is your sigma squared, and now we need to divide by sigma. So therefore that is square root of 56.875. Okay, then now here when you calculate, that will be PZ less than 2.122. And then now when you refer to the graph, normally right after you standardize the variable, the normal variable, then you sketch a graph. Because of less than, so the region is towards left side, and now the critical line has this value 2.122. Therefore, the region is given in the table. Then you can just read the probability from the table to get this value and round up to 3 significant figures, that is 0.983. So this is the solution for this question. Question 6. At a fun fair, Amy pays $1 for 2 attempts to make a bell ring by shooting at it with a water pistol. If she makes a bell ring on her first attempt, she receives $3 and stops playing. This means overall she has gained $2. Okay, now if she makes the bell ring on her second attempt, she receives $1.50 and stops playing. Okay, then she has gained 50 cents. If she does not make the bell ring in the 2 attempts, she has lost her original $1. Okay. Now, because $1 for 2 attempts, so the probability that Amy makes the bell ring on any attempt is 0.2 independently of other attempts. First part show that the probability that Amy loses her original $1 is this. So when loses means that she does not make the bell ring in both attempts. So which means, right, first part, your probability of making bell ring is 0.2. That means this is a probability success. Therefore, probability of failure means does not ring the bell. That is 1 minus 0.2, which is 0.8. Now, she loses $1 ringgit, $1, right? She loses $1. So when loses $1 means that she does not make the bell ring. So which means both attempts are failures, right? So the probability, it will be Q squared because both also failures. That is 0.8 squared, then you will get 0.64. So done for the first part. Now part 2, complete the probability distribution table for the amounts that Amy gains. Now this is gain, okay? So 0.64 already counted losers. Losers means minus 1 because now it's gain. So here minus $1. After that, refer to here, gain 50 cents, right? So when you look at the table here, this is dollar sign, that means 0.5. And then lastly, it will be gain $2. So gain $2. Now, when it is P gain is 0.5, that means, okay, look at here. She makes the bell ring on her second attempt. On her second attempt means that first attempt was failure, right? So first attempt was failure means that first it will be Q. Second is probability of success. Then this is going to be 0.8 times 0.2 because the probability of making the bell ring is 0.2. Then here you will be getting 0.16. Now when PG equals to 2 or P gain equals to $2, right? That means she makes the bell ring on her first attempt, right? So on the first attempt, I will just consider first attempt because you will be directly getting the, look at here, she received $3. When she makes the bell ring on her first attempt, she received $3 and stopped playing. So she will not play the second time because that is what she can get, right? So it means that now I will just consider first time is already success. Therefore, this is going to be 0.2. So now when you add up these three values, it will be 1. Okay, so that means your probability distribution table is correct. Now, calculate Amy's expected gain. So expected gain is basically summation of the gain, right? Gain times the probability. Okay, so gain times the probability. Right? So then from here, I will just multiply. So multiply these three values. I mean, these three pairs of values. So it will be minus 1 times 0.64 plus 0.5 times the probability is 0.16 and then 2 times 0.2. Then here you will be getting negative 0.16. So this means it will be negative of 0.16. So Amy's expected gain is basically she expects to lose 16 cents, right? Okay, now question 7. The weight of adult female giraffes has a normal distribution, this for female, with mean 830 kilograms and standard deviation 120 kilograms. First part, if there are 430 adult female giraffes in a particular game reserve, find the number of these adult female giraffes which can be expected to weigh less than 700 kilograms. So before you find the number, okay, we need to find the probability first. Then after you found the probability, only you times with this 430 to get the number. Okay, so now your female, let's say F, is normally distributed with mean 830 and variance 120 squared. So now property of female, the weight is less than 700 kilograms. So now here, since this is normally distributed, again I will standardize it. It will be less than 700 minus 830 over the standard deviation is 120. That means now here you will be getting z less than negative 1.083. Okay, and it is a value, it is a negative value. So I will sketch a graph, right, and mark negative 1.083, and it is less than. Less than means the region will be towards the left side. So since this line is on the left side, which takes negative value, I will reflect it to be positive. Otherwise, it is not available in the table. And then when you reflect the region, it will be the orange region. Okay, so now the blue region now is because it's same as the orange region. Orange region is same as PZ more than 1.083. But the table, okay, the normal table just give you whatever less than the positive value. So I will use this concept, total probabilities, which is 1 minus whatever less than the 1.083. So therefore, this is 1 minus PZ less than 1.083. And now the probability can be found from the table, the normal table. Then you will be getting 0.8606, and now you minus from 1. That is going to be 0.1394. Okay. Then now, the question is asking for number of female giraffes, and it's not the probability. So now, this 0.1394 means that for one giraffe, okay, the probability of the weight is less than 700 kilograms is 0.1394. But now we are considering 430 giraffes. So means that I will have to times by 430. So 0 times the probability with 430, then you will be getting 59.942. So I will say that it is almost 60. Right, correct to 3 significant figures. Or I will say that the giraffes cannot be in decimal. So because after the dot, the decimal point, it is 9. So I round up into 60. Now, given that 90% of adult female giraffes weigh between these two values, find the value of W. Okay, so now I will write P, your female, the weight is in between these two values with probability of 0.9. Okay, so now I will standardize it. So when we standardize, so here is you have to minus mean. So remember just now the mean 830 and variance 120 squared. So I have to minus 830 then over 120. That is how I standardize it. Then here you will be getting P. The first one is minus W over 120. And then the next one is W over 120. And the probability is 0.9. Okay, so from here, right, I will sketch a graph. So it is in between two values. One is negative W over 120. Another one is W over 120. So since it is symmetrical at the 0, that means now the total regions here is 0.9. Okay, and since it is normally distributed, I need to know the total region from positive up to the negative. So now the middle value is 0.9 means that the other two parts, the left and right side, it will be total of 0.1. So 0.1 divided by 2, that is 0.05. So I know that total region is actually 0.95. So now from here, I will just write PZ less than W over 120 is basically 0.95. And now this 0.95 is available in the table because the region is towards the left side. So from here, I will just write from table PZ less than 1.645, that is 0.95. And now when you compare, right, so 1.645 is basically W over 120. Then from there, we can solve for the W. So I will write W over 120 equals to 1.645. Therefore, my W is 120 times 1.645. That is going to be 197.4. And now I round up to 3 significant figures. That will be 197. So that's all for this solution. Okay, now the weight of adult male giraffes has a normal distribution with mean 1190 kilograms and standard deviation sigma kilograms. So now male, let it be M, normally distributed 1190, then variance is sigma squared. Now given that 83.4% of the male giraffes weigh more than 950 kilograms, find the sigma. So which means P, M more than 950, that is 83.4 over 100. Convert the percentage to decimal. This is going to be 0.834. Okay, so then from here, I will standardize the M. So standardize the M, it will be Z more than 950 minus 1190 over sigma. Probability is 0.834. And now, when I draw the graph, to get the idea where is the line, okay, when it is greater than 0, the Z greater than 0, the probability is 0.5. But now you see Z greater than this value, okay, so probably I can simplify. This is greater than negative 240 over sigma. So obviously the value is on the left side because we know that sigma will be positive. Or probably you can just refer to the probabilities of 0.834. Okay, it is greater than 0.5 and some more here is greater. So greater means from the line onwards. Therefore, the line is basically on the left side. And this orange color, the region is with probability of 0.834. So now, when the line, okay, this critical line, negative 240 over sigma is on the left side, we need to reflect because the negative value is not available. So when I reflect, it will be on the positive side. And then the region will be the bigger region as well. So from here, I will just write PZ more or less than, okay, 240 over sigma, that is 0.834 because that is the reflected region. And now here, I can just read the table because the line is positive, the critical value is positive, and the region is towards left side. So it will be PZ less than 0.97 and the probability is 0.834. Okay, then now I will compare these two values, just compare to get the sigma value. So 240 over sigma, that is 0.97. That means now the sigma is 240 divided by 0.97 and you will be getting 247.4. Now here you can round up to 3 significant figures. That is going to be 247. So this is our sigma value or standard deviation. Okay, so done for this question. Now question 8. Freddy has 6 toy cars and 3 toy buses, all different. He chooses 4 toys to be taken to take on holiday with him. In how many different ways can Freddy choose 4 toys? Okay, so basically there are total of 9 toys here. Okay, and he is choosing 4. And we must remember all the toys are different. So because all the toys are different, then we can just use a combination to solve. So therefore, the first one is number of ways. Basically, this is number of selections. It will be 9, choose 4. Then you will be getting 126. Okay, so we can use a C, the combination when you are given all different objects. Part 2, how many of these choices will include both his favorite car and his favorite bus? Okay, means now 6 toys, cars and 3 bus. Okay, 3 toy buses. Then from here, let's say he has C1, right? Then his favorite is C1. And then the bus, 3 buses, his favorite is B1. That means now here you have 5 others. And for the buses, you have 2 other buses. So must include both C1 and B1. That means C1 and B1 are chosen. So you need to choose 2 more. So these 2 more never mention whether they are both buses or both cars or 1 bus, 1 car. Therefore, these 2 must be chosen from the total of the others. Okay, so which means from 7 I just need to choose 2. So then the number of selections, it will be just 7 choose 2. That will be 21. Now Freddy arranges these 9 toys in a line. Okay, means arrange all. Find the number of possible arrangements if the buses are all next to each other. Okay, now you have 6 cars, 3 buses. So if the buses are all next to each other means that I will put them in a group. Then here you have 6 more cars, 6 cars. Okay, but then the question doesn't mention. It must be all buses first. So it means that 6 plus 1, it will be 7. So I am arranging 7 of them. So that means it will be a number of arrangements. It will be 7 factorial first. Okay, after that, look at the 3 buses in a group. So these 3 buses you can arrange among themselves. Therefore, times 3 factorial, because these 3 are different buses, right? That means you are getting 30240. This 3 factorial is to arrange the 3 buses. Alright, so that's all for this part 3. Part 4. Find the number of possible arrangements if there is a car at each end of the line and no buses are next to each other. Okay, so now we have 6 cars and 3 buses. Okay, so mention that there is a car at the end of each line. End of the line. Okay, each end of the line. That means probably this is C and then here is C. So from 6C, you have fixed 2C here. Alright, then here means that I will have another C1, C2, C3, C4. I have another C, 4 Cs. So from here, I will say that, okay, basically you can say for the first C, I have I will write number of arrangements. For the first C, the front one, I have 6 choices. And then for the last C, I have 5 choices. Okay, then I have C1, C2, C3, C4. So these 2C already fixed. We are not going to change. We already consider, okay, 6 choices and 5 choices. And then now for the C1 until C4, we have 4 factorial choices, because you are arranging all 4 different toy cars. And now no buses are next to each other. That means your bus will be in between all this. Okay, cannot be before the first C and after the last C, because it's already mentioned car at the end, right? So you cannot say here these two are wrong, right? So then the orange color will be for the bus. So but then we need 3 buses. So from here I have 1, 2, 3, 4, 5. Therefore I will write 5. Now I need 3 slots, but then since all the buses are different buses, so you have to use P. 5P3. Okay, because after you have chosen 3 slots, then you have to arrange for the 3 buses. That means now here you will be getting 43200. So you can use this method, or we have another method to solve this question. Okay, that means now I will write C1, C2, C3, C4, C5, C6. Okay, as long as there's a car at the end. So it means C1, C6. So basically, I'm arranging all 6 cars. So number of arrangements equals to 6 factorial. Okay, then followed by the bus. So for the bus, okay, the first one cannot be accepted because the C must be the end of the line. So all these are for the buses. So the buses will be 5P3. Right? Then you will be getting the same answer. So basically 6 times 5 times 4 factorial is the 6 factorial. So it depends on how you solve this question. Okay, so I have completed this paper. So and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and recommend this channel to your friends if you enjoy watching my videos. And also stay tuned for more upcoming videos. Thank you everyone. Bye.